Welcome back and welcome to lesson 3.1. 3.1 says this: I can identify the states of matter and phases present on a heating or cooling curve. If we look at our descriptor list, we notice that this is the first lesson of Unit 3. Let's toggle back to the notepad and let's get started. When I think about the main idea behind 3.1, a specific scenario pops into my head. And what I think of is a boiling pot of water. So here you see on the right side, there's a pot and there's a burner underneath it. When we turn on that burner, what we can do is over time boil the water. We can track the temperatures using a digital thermometer. So if this was sitting in here, it would give us a readout. And what we can do is we can track a temperature every minute or so. Let's go ahead and add subtitles and a title to our graph. The x-axis is going to be time in minutes, and our y-axis is going to be temperature in degrees Celsius. And remember, when you make a title, you want to look at your subtitles and list those in the title. So we'll call this temp versus time. Here are three key temperatures you need to think about. Water at 0 will freeze. Water at about 25 degrees Celsius is at room temp. Water at 100 degrees Celsius will boil. At this point in time, I'd like you to pause the video, make a prediction of a graph. So draw in your line. And here's our scenario again. We're taking a room temperature pot of water, we're tracking the temp, and we're boiling it. What would it look like? So hopefully you've drawn your graph at this point. And what I'll start off by saying is that most people who've never taken a chemistry class would predict the graph to look like this. A straight line that keeps going up and up. If we take the data using this instrument, a thermometer, what we actually find is that this graph looks a little bit different. So let's go ahead, let's erase this, and this is what it would look like. We would have a diagonal going up to 100, but as soon as we hit 100, we find that the graph actually plateaus. There's an incline, and then there's a flat part that continues. The water would eventually boil off, and then the graph would keep going up and up. Let's now go ahead and expand this idea even further. We're going to broaden the heating curve for water and see what it looks like in full. So we can label here at the top is that this is the full heating curve of water. Let's go ahead and label some key temperatures that we know. So water freezes at 0 degrees Celsius. So this is freezing. And we know that water boils at 100 degrees Celsius. And room temperature will be somewhere in between. And room temperature is 25 degrees Celsius roughly. The biggest distinction at this point that I would like you to make is to realize that the heating curve for water is not a straight line. Notice that there are kinks in the line, and it is not a straight line at all. Notice how different those two things are. We'll go ahead and we'll erase this line. And let's begin to highlight and label some specific sections of the graphs. So let's highlight all the inclined portions. So here's one, A to B, C to D, and then E to F. Every portion of the graph we just highlighted in green is considered a temperature change. So whenever we get an incline in a heating curve, we know that there is a temperature change. We'll color code this green to remember that this corresponds to the green sections of the graph. Now we're going to take our yellow highlighter and we're going to highlight the flats of the curve. A flat section is considered a phase change. What this means is that we are in between two different types of phases. We're going from one to the other. When we start at point A and we take an ice cube out of the freezer, we will have just solid particles. When we apply heat and get to a plateau, this flat section, you will have not only solid but liquid. It's kind of half and half here. As you move from C to D, what happens is there are just liquid particles. We hit another flat section between D and E. We see that we're split in between liquid and gas. And then when we get to E and F and above, what you'll notice is that we have just gas particles located in this section. Let's go ahead and label our states of matter for every section. So from points A to B, it is just solid. Make some room here. In section B to C, there's two states of matter. There's solids plus liquids. In section C to D, what we have is just a liquid. In section D to E, we have not only a liquid, but a gas particles. And then from sections E to F, we have just gas. We can now add some critical notes to the original notes we wrote here describing the graph. So for every inclined section we see, we know that there's a temperature change, and that also means that there's only one state of matter. For the flats, we know that there are phase changes, and we know in every one of these yellow sections, you will always have two states of matter. To conclude the video, the most important thing you could take away from this lesson is that heating curves are not straight lines. There are distinct sections where temperatures increase and distinct sections where temperatures stay the same. Thank you for watching the video. We will conclude here. Please look out for part 2. We will be discussing a cooling curve. And as always, have a great day. Thank you.